So the first 6 questions, well, first 12 questions are over factoring. But let's just look at the first 6 to start with. Are there any questions on problems 1 through 6? Any of those that y'all want to look at in particular? So we look at number 1. Now the first thing we need to do when factoring is factor out a greatest common factor, if there is one. So we look at problem number 1, and we look across these 3 terms, there is a greatest common factor of 7. So we can factor the 7 out. So factor it out of 7b squared, we're left with b squared. 7 factored out of negative 63 would leave us with negative 9b. And 7 factored out of 140 would leave us with 20. We're pulling it out, or we're dividing every single term by 7, whatever that greatest common factor is. So now we got the greatest common factor out, which moves us to step number 2, which was our 2 sets of parentheses with 3 spaces. So we'll write that down there, 2 sets of parentheses, 3 spaces, and 3 spaces. So that was steps 1 and 2. Now step number 3 is going to be to find the sign. Since the constant term is positive, or really the third term is positive, the signs are the same and they match the sign of the middle term. So they would both be negative, negative, and negative. So that takes us through steps 1 through 3. Now the next step that we did in solving this here would be find the factors of the first and third term. Well, the factors of b squared would be b and b. The factors of 20 are 1 and 20, 2 and 10, 4 and 5. So we have 3 different sets of factors. Now which ones do we want to try? 4 and 5. And lastly, we check. B times negative 5 would be negative 5b. And negative 4 times b would be negative 4b, which gives us negative 9b. Is that what we wanted? Mm-hmm. So this here would be the answer. That would be the correct answer. Questions on this here? Are there any others for 1 through 6 that we want to look at? Any of those that we want to look at or see how they got worked? Number 3. So we look at number 3. Is there a greatest common factor between all 3 terms? No. So we can't factor anything out. So we move on to step number 2. 2 sets of parentheses with 3 spaces. Now since the constant term, or we can say the third term, is positive, or the last term or sets of terms is positive, the signs are the same and they match the sign of the middle term. So they would both be positive. Now we look at the factors of the first term and the third term. Well, I know for sure I'm going to have h and h, because that's the only way we get h squared for the first term, yes? Now the factors of 3 are 1 and 3. Are there any other factors? No. So we can just put those in. Now the factors of 6 are 1 and 6 and 2 and 3. Which ones do we want to try first? 2 and 3. Which one do we want to put here, or put in first? 2 and 3. Could I put a 3 in the first one? No, because 3h and 3 would have a greatest common factor, wouldn't they? Because they'd have a greatest common factor of 3. And as we kind of saw, or I pointed out, if there's not a greatest common factor to begin with, there can't be one in either one of the sets of parentheses. And even if we factor out a greatest common factor, we've already got it factored out, there can't be one in either of those either. Does that make sense? Now, if it works out that you get to this point, okay, we say no greatest common factor, and it comes down here, and there's only greatest common factors no matter how I set it up, take a look back at the beginning and see, was there one I overlooked? And that might be the case. It might also be the case that it is not factorable. Does that make sense? So we can look and see. So we have to set it up this way. Now when we check, 3h times 3 would be 9h. 2 times h would be plus 2h, which gives us 11h, which we wanted. And that's all we have to do for this here. Any questions on this here? Any questions on anything we've done so far? Are we good with these here? Any other questions on 1 through 6? Problems 1 through 6? If we're good with 1 through 6, how about 7 through 12? 7 through 12, any of those that we want to look at? Any questions on 7 through 12? Number 10. Now, number 10 is a little bit special, but it is a difference of perfect squares. Because a squared is a perfect square. It's a times a. 25b squared is a perfect square. 25 is a perfect square. It's 5 squared. And b squared is just b squared. It works out it is a difference of perfect squares. Or we can do our 2 sets of parentheses. Since this term is negative, it works out the signs are opposite. And our factors of a are a and a. And we'd have 5b and 5b. As it works out that it is a difference of perfect squares. And our difference of perfect squares says that when we have a squared minus b squared, it's going to equal a minus b times a plus b. Just the first term, whatever it is, squared. Now, we're not going to have a problem like this here, I don't believe, where we have 2 different variables in the same equation on the test. But if we did, it would work out kind of like this here, which isn't too bad. Nope. So we won't have one like 10 on the test. There might be one kind of like the rest of the difference of perfect squares, kind of like 9 or 8, kind of those. Those will be on the test, and they work the exact same way. Any questions on any of this here? Any others on number 8? So looking at number 8, is there a greatest common factor? No. Now, when I look at this here, I notice that 4n squared is a perfect square, isn't it? Because I can rewrite it as 2n times 2n. Is 49 a perfect square? So this here is a difference of perfect squares. Because I know that I could really rewrite the first one as 2n squared, and I could rewrite the other one as 7 squared, yes? So since I see that, I could really say 2n minus 7 times 2n plus 7, using the properties of the difference of perfect squares to solve this. Now, say we didn't notice that. I have it set up here. Now, the constant term is negative. The last term is negative. So the signs would be opposite, positive and negative, yes? Well, the factors of the first one, I'd try 2n and 2n, 7 and 7. And then we could check it. 2n times negative 7 is negative 14n. Then we'd have 14n, which would give us 0, just like we wanted. So we could still use factoring to solve it. But if we do notice that it's a difference of perfect squares, it's kind of helpful. Any questions on this here? Does that make sense? Yes? Okay. And I'm relearning this board because when we lost power this morning, it literally reset this thing. No, I mean I had to redo the connection to it. Opposite, yeah. When the last term, for us, it'll be a constant term. We won't deal with anything kind of more complicated than this. because we'll have a constant term in each and every single one of them. We'll have a term without a variable for what we're covering in here. Now, it could be, need to do that. Like we could have x squared plus 4 this here. This is above what will be on the test and what we'll cover in here, but we can still factor it. We just have to change a little bit of the terminology because there's not a greatest common factor, so we do our 2 sets of parentheses. Now, we wouldn't talk about the constant term for the sign, but I'd really be just looking at the last term in the set of 3. And here it's positive, so the signs are the same, and they match the sign of the middle term. Now, the factors of x squared would be just x and x. Now, because I have 4y squared, I can have y and y, because y times y will give me y squared, yes? Now, it works out that the factors of 4 that we're going to use are 2 and 2. And when we multiply this, x times 2y will give me 2xy. 2y times x is going to be plus 2xy, which gives me 4xy, which is our middle term. So it still works out that we can still do the same processes for this, even if we do have a variable, 2 variables. Questions on this here? So for the most part, what we'll be factoring won't be having 2 variables. We'll most likely be doing something like this here, or the ones before, where we only have it in terms of a variable. Any other questions on 7 through 12? Or any of those that you all want to see worked? If not, we can look at 13 through 16. Any questions on 13 through 16? How would we do any of these here? You can just type it in the calculator. Because I can type in 1,089 squared minus 961 squared into the calculator, it'll give me the answer. I can do any of these in the calculator, and it'll tell me exactly what the answer is. Now, if I wanted to do this by hand, if for some reason you weren't allowed to use a calculator on the test, this here is just a difference of perfect squares. So we can say 64 minus 25 times 64 plus 25. Well, 64 minus 25 would be 39. 64 plus 25 would be 89. And all I need to do is actually multiply these together. 39 times 89. 81. 9 times 3 is 27. 35. 0. 8 times 9 is 72. 8 times 3 is 24. 34. 1, 7. So we should get 771, I think, for the first one. But it would be a lot easier to just grab a calculator and say, do 64 squared minus 25 squared. Nope. Yeah, it is, 3471. Yep. 39 times 9, 351. 39 times 80, that should be a 1. But any questions on these here? We're just typing these into the calculator. So those aren't bad. Okay. Any questions on 17 through 23? Which one do you want to do? So 17? So what method can we solve 17 by? Yeah. We can do the quadratic formula. That will work. So if we plugged it in, because the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. We could do that. All right. There's nothing wrong with doing that there because that will work. Now, one way that we could do it is, as it finishes loading, plus 3x plus 2. We could graph it. So x squared plus 3x plus 2. Graph. So where does it cross the x-axis? Well, we can see it crosses at 2 points, yes? Real close in the negatives. So I can go second graph and look at the table. As again, we're looking for what value of x makes the function equal 0, or the y value 0. I have two of them here, don't I? Negative 2 and negative 1. That's the answer. So, pull the graphing calculator back up. So to type a function in, we hit y equals and type it in to the first one. So we do x squared plus 3x plus 2. You get x, you can do alpha and then stow or the x t theta n, x tau theta n. We'll also do x. And we can type it in. There's nothing wrong with doing this by the quadratic formula because we could type it in. And you'll get the exact same thing. It's going to give you the same answer of negative 2 and negative 1. So you'll get the exact same answers using the quadratic formula as you would with graphing. And it's going to work out that graphing will give you the correct answers pretty much immediately if the values of x, the solutions for the quadratic, are whole numbers. Because if they're whole numbers, it will give you the answer pretty much straight away. It'll tell you what it is on the table. Questions on this here? Now, if we look at the other one, number 18, 0 equals x squared minus 9, we could graph it, and it would give us answers. It would actually give us what the answers are, the solutions. Or we can use completing the square, or we can use the quadratic formula. I would use the square root method, because I can add 9 to both sides, which will tell me that x squared is equal to 9. Square root both sides, and x is equal to plus or minus 3. If you typed x squared minus 9 in the graphing calculator, it would cross at negative 3 and 3. It will tell you what the answers are. It'll give you these answers. And even if it's not 0 equals, you can move everything over and make it 0 equals and plug it in. Questions on this here? Any other questions on up to 23, I think is what it was, wasn't it? Any questions on 19 through 23? Yes. Now, since I have a set of parentheses squared, I'm going to use the square root method, because that's going to be the easiest one to solve for this here. since I have a set of parentheses squared, I'm going to use the square root method because that'll be the easiest way to solve this. So we'll get the set of parentheses by themselves first. Well, the first thing I need to do is I need to subtract 2 from both sides, because these will cancel, leaving me with 4 times x minus 1 squared is equal to 8. Well, at this point here, the set of parentheses is not by itself. It's being multiplied by the 4, so we're going to divide both sides by 4, which will give us x minus 1 squared is equal to 2. X minus 1 squared is equal to 2. Any questions on this here? Well, is the set of parentheses by itself? Yeah. So that means I can square root both sides because the square root and the square will cancel out, leaving me with x minus 1 is equal to what? Plus or minus the square root of 2. The square root of 2 will not simplify, it won't reduce, because 2 is not a perfect square. 2 is technically what? It's even, but we'd also consider it what kind of number? It would be prime. It'd be an even prime number. Most likely the only one. And then to get x by itself, we can add 1 to both sides, which tells me x is equal to 1 plus or minus the square root of 2. And that's it. That's all we have to do for this here. Now, unfortunately, trying to graph it wouldn't graph because those are not whole numbers. Those are decimals. Those are non-repeating, non-terminating decimal numbers. So we can't have that down. Any other questions on these here? Number 42. Okay. While we're here, why don't we look at 19? Did anybody try 19? I'm going to move the subtract 2x first to get 1/5 x squared minus 2x plus 6 is equal to 0. Now this here looks like it's going to be quite a challenge, yes? I think probably most of y'all avoided it because it looked difficult, yes? You can. And the graph is something like this here. So that means we have no real solutions. But it wasn't asking for the real solutions of any of these here. It's asking for the solutions. So we still have to find them. So what is going to make this one challenging is the 1/5, because if we try to plug this into the quadratic formula, we're going to have fractions on top and bottom. We'll actually have a fraction inside of a square root, which doesn't work well. Now, the ones that we'll have, we won't deal with this, but if you take college algebra, they'll throw something like this at you or throw decimals at you. And what you can do is you can multiply it by a scalar. Because, looking at this here, what is 5 times 1/5? 1, because they simplify out, don't they? So I'm left with x squared. 5 times negative 2 would be negative 10x. 5 times 6 is plus 30. Did that make that problem a lot easier? Yeah. There's nothing wrong with multiplying by a scalar or multiplying everything by a number so that the decimals or the fractions go away. It doesn't change the solutions. Because at this point here, we can use the quadratic formula. So negative b, so negative 10 would be 10 plus or minus the square root of negative 10 squared minus 4 times a times c, which is 30, all over 2 times 1. Now at this point here, we can simplify what's inside the square root, and we'll get negative 20. If we type in parentheses, negative 10, close parentheses squared, minus 4 times 1 times 30, we'll get negative 20. We'll get negative 20. Now, one thing I do know that will come out of that radical is going to be I, because anytime we have a negative number inside of a square root, the I is going to come out. It's always going to come out. Now, if you typed in negative 20, or the square root of negative 20 in the graphing calculator, it gave you a decimal. If you tried typing in the square root of negative 20 in the TI-30XS, the yellow calculators, it would have given you domain error. It can't do negatives. But one thing I can do is I can move that negative outside as I, and that leaves me with what? The square root of 20, yes? The yellow calculator will do that. And if you type the square root of 20 in the yellow calculator, it's going to tell you that it's 2 square root of 5. And we have to include the I because we brought it out first. So the square root of negative 20 is 2I square root of 5. Any questions on this here? Any questions on this here so far? Now there is a greatest common factor of 2 that we could factor out. And the 2 and 2 would cancel, telling me that x is equal to 5 plus or minus I square root of 5. That we can simplify down to. I would try to simplify down as far as you can. If for some reason you don't notice it, I'm not going to count all for it, but I would like it simplified all the way down. Any questions on this here? Now, we're not going to have ones that have a fraction or a decimal on any of the ones that you are having to solve for the values of x. Okay? So you're not going to have one that's going to say use the quadratic formula to solve this one, solve for the value of x, and it gives you fractions, or using the completing the square, or factoring, or graphing with fractions. Now, if it gave us decimals, like this here, it would be just as easy to get the decimals away. I just would multiply everything by 100. Because again, anytime I multiply by 10 or 100, it moves the decimal over. So here it's going to move the decimal 2 spaces, which direction? 2e? Right. So this would be x squared minus 28x plus 150. Now that's a little bit easier to work with, yes? So that's all we'd have to do to solve this. Now we use 100 because the middle term needs the decimal moved twice. Because 0.21 would need to move it twice. Questions on this here? So we wanted to look at 23. Is that the one you wanted? Or is it 21? Yes. 22. So we can look at 22. Now we could try graphing it, and it's not going to have real solutions. Now, I do notice that there's not a middle term. There's not a term with just x, so we could use the square root method. And the first step in the square root method is to subtract 100 from both sides. And when I do that, I get x squared is equal to negative 100. And then we can square root both sides, and the square root of x squared will cancel, giving me x is equal to plus or minus? Well, the negative is going to come out as I. Mm-hmm. Yep, square root of negative 100 is 10I, plus or minus 10I. That's it. That's all I have to do for this here. Any questions on this here? Any questions on the problems up to 23? We're good with these here? Yes. Questions on 24 or 25? Completing the square. Which one do we want to look at? Or do we want to look at both of them? So 25. So we're going to use completing the square because it told us solve the following quadratic equations by completing the square. Now, with completing the square, one of our steps is actually getting the constant term onto the other side. We already have that, don't we? Constant term's already over there. So we're good there. So I'm not going to move it. I'm not going to set it equal to 0. Because this is one of the few problems or a few types of methods of solving it where it doesn't equal 0. So we're going to leave it there. Now, the first step in completing the square is A equal to 1? No, it's equal to 5, isn't it? So make it so. We need to make it equal to 1. So we would divide every single term by 5. When we do that, we'll get x squared plus 6x plus. Now I'm going to leave blanks in there because since the constant term is already on the other side, we kind of got through step 2, and we can put our spaces in. What do we need to do next? We need to find the value of c. And c is equal to b over 2 squared. Now for us here, what is the value of b? 6. Well, 6 divided by 2 would be 3, and 3 squared is 9. So we'd have 9 and 9. Any questions on how we found the value of c and plug this in? We good with this here? Now, because we're talking about completing the square, we're wanting to rewrite this as a set of parentheses squared. And we'd have x. And then what was inside the parentheses before we squared it kind of tells us what's going to go in with x. So it'll be plus 3. Since the 3 inside the parentheses was positive, when solving for the value of c, it'll be plus 3. Now, negative 10 plus 9 is going to be negative 1. Any questions on this here? Now, at this point here, we can square root both sides. Well, the square root and square will cancel, leaving me with x plus 3 is equal to plus or minus. Well, the square root of negative 1 is I. Square root of negative 1 is I. And last but not least, what do we need to do to solve for the value of x? We need to subtract 3 from both sides, which tells us x is equal to negative 3 plus or minus I. And that's it. Questions on this here? So for this one here, you need to solve the equation by completing the square, by this completing the square method. Now, if it works out to be whole numbers, you could do it that way, but you will lose the points for doing it by the correct method. You'll still get the points for getting the correct answer in the rest of them, but you'd lose the few points associated by doing it the correct way. Okay? So we could do that, but the first step is a equal to 1. So I would divide by 2 first. Divide everything by 2, which will give us x squared minus 6x minus 12 equals 0 first. Then we can move it over because we will need to move it over. We would add 12 to both sides. Base equals 12. Because that would be our next step. Because again, we are eventually going to move it to the other side to do completing the square. Now at this point here, we still need to find the value of c, which is going to be b over 2 squared. Well, the value of b is negative 6. Well, negative 6 divided by 2 would be negative 3, and negative 3 squared is 9. Now 12 plus 9 would be 21. Now for the other side, we can factor x squared minus 6x plus 9 down to a set of parentheses squared. And we would have x minus 3 this time, because inside the parentheses before we squared it was negative 3. So we'd have x minus 3. Now at this point here, we're going to take the square root of both sides. And when I take the square root of both sides, well, the square root and square would cancel, leaving me with x minus 3 is equal to plus or minus the square root of 21. Now, it works out that we can't take the square root of 21. It just doesn't simplify down any further than this here. But we do still need to add 3 to both sides. And we get x is equal to 3 plus or minus the square root of 21. And that's as far as we can go, because we can't simplify the square root of 21. It just doesn't simplify. Any questions on this here? Any questions on how we did this one here? (26) or 27, solving the following equations by completing the square. We have questions on 26 or 27. Either one of those that we want to look at. 27. Now, when we're using completing the square, we need this equation equal to 0. So I need to get everything on the same side of the equal sign. Well, the easiest way to do that would be to add 4x squared to both sides. That's going to be the easiest way to do this, which will give us 4x squared minus 7x plus 6 is equal to 0. We need to get it equal to 0. That's going to be the first main step. Now that we have it equal to 0, we can use the formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b, negative 7 would be positive 7, yes? A negative and negative would make a positive. Then we would have negative 7 squared minus 4 times a, which is 4, times b, which is 6, all over 2a. And that would be 2 times 4, which would give me 8. Any questions on how we got to this point here? Well, the next thing I would do is I would simplify everything inside the square root. I wouldn't take the square root of it yet. I would simplify everything inside of it first. So I would do negative 7 squared minus 4 times 6 in the calculator, which would be 49 minus, well, 4 times 4 is 16, 16 times 6, so it would be negative 47. Now we will get I out of that square root because anytime there's a negative inside the square root, it'll always come out as I. And then we can plug the square root of 47 into one of the yellow calculators, and it will tell us that it's just the square root of 47. It doesn't reduce. It does not reduce. And that's it. Because there's no other way to simplify or reduce it any further than that there. Any questions on this here? Any questions on this here?